Hello my dear students, welcome back to Fluid Mechanics lecture series. I am your Sumam. We are continuing fluid kinematics. What is fluid kinematics? We have learned previously that fluid kinematics deals with the study of fluid motion without considering the forces which causes the motion. It deals with the study of how the fluid flows and how to describe the fluid motion. The topic for today's discussion is type of flow. Fluid is composed of different particles, moves at different acceleration, which may change with respect to space and time. So, the motion of the fluid particle in space may be described in three dimensions in the direction of three mutually perpendicular coordinates x, y, z drawn from the position of the particle at any instant of time. Based on the coordinates, we can classify the flow as one-dimensional, two-dimensional and three-dimensional. So if you are considering the variation of flow characteristics in x, y and z direction, then we can call that flow as three-dimensional flow. Whereas if you are considering the variation of flow characteristics in two directions only, that is xz or xy, then we can call that as two-dimensional flow. So if you are considering the changes in flow characteristics in one direction only, that is in x direction alone, then we can call that as one-dimensional flow. Now let us discuss what is three-dimensional flow. So as we discussed, in three-dimensional flow, the flow characteristics, that is velocity, acceleration, pressure, temperature, density, etc. changes and they are function of x, y, z. At any instant of time t, then this flow characteristics can be represented as the function of x, y, z, t. So let us consider the flow characteristics, that is the velocity. So since we are considering the variation in x, y, z direction, this velocity v has the components u, v, w, that is in x direction and y direction and z direction. So velocity is a vector quantity. So velocity vector can be represented as v equal to ui plus vj plus wk, where I, j, k are the unit vectors in the direction of x, y and z. So at any instant of time, the flow velocity v has the component u in x direction and the component v in y direction and component w in z direction. So u is a function of x, y, z, t. Similarly, v and w, that is also the function of x, y, z, t. So one of the example of three-dimensional flow is the sudden entry of flow, that is flood to a channel with an existing flow. So that type of flow can be represented if you are considering the changes in flow characteristics in x, y and z direction. Another example is the flow that is taking place in a stream basin. So when the water reaches the maximum reservoir level of a dam, then spillway gates are opened and the water is allowed to flow into the stream basin. So stream basin is a pool of water that is available at the downstream of this spillway. So the main function of stream basin to absorb the energy of the flowing water. So the flow that is taking place in a stream basin when the spillway gates are open, that is very well represented if we are considering the fluid flow as three-dimensional. All the real flow are three-dimensional. Let us watch this video, that is the flow that is taking place through a sloping stream. So if we are analyzing the flow as three-dimensional, then it can capture all the flow characteristics as a real fluid. However, in many engineering problems, major changes in flow characteristics are the functions of either x and y or x and z. So in that case, we are considering the flow as two-dimensional nature. The flow characteristics, that is velocity, acceleration, pressure, temperature, density, at any instant of time is represented as a function of x, y, t. So velocity has the component u in x direction and v in y direction. So velocity vector can be represented as v equal to ui plus vj, where I and j are the unit vectors in x and y direction respectively. Consider the flow through a pipe. So the pipe is running full and pipe is horizontal. So if you are considering the variation of velocity along the length of the pipe and across the section, then if you are plotting the velocity profile, it will follow the shape of the parabola. That means the velocity which is 0 at the boundary and it will be maximum at the center of the pipe, which more or less represents the true nature of the flow characteristics. But if you are considering the variation of the flow characteristics in one direction alone, that is in x direction, then we can call that flow as one-dimensional flow. So in that case, the flow variables at any instant of time is represented by a function of x comma t. So the best example of one-dimensional flow is the flow that is taking place over a horizontal surface. So there is no change in the direction of the flow. It is flowing in one direction. So velocity vector can be represented as ui, where I is the unit vector in the direction of x. The figure shows the flow through a pipe, and we are plotting the velocity profile by considering the flow as two-dimensional. So the pipe is running full. The same flow, if you are analyzing as one-dimensional, then the velocity, that is, we are represented like this, whereas we know that the velocity at the boundary is 0. But that cannot be represented if you are considering the flow as one-dimensional. So that means true nature of the flow that cannot be represented by considering the flow as one-dimensional. So that is the difference. So if you want to represent the real flow accurately, in order to capture the real flow characteristics, we have to analyze the flow as three-dimensional. Otherwise, we have to go for two-dimensional or one-dimensional. For one-dimensional flow, accuracy is less compared to two-dimensional as well as three-dimensional. Real flow is three-dimensional flow. So next type of flow we are discussing is uniform flow and steady flow. Conditions in a body of fluid may vary from point to point, and at any given point it may change from time to time. So based on which we can classify the flow as uniform flow and steady flow. So if the flow characteristics, for example velocity, at every point is same in both magnitude and direction, then we can call that flow as uniform flow. So if n represents the flow characteristics, then for a uniform flow, dou n by dou s, that is equal to 0. The best example is the flow that is taking place through a pipe. So the pipe is running full. So the cross-sectional area of the pipe is same throughout the length. So if you are considering different sections and measuring the velocity, it is same throughout. So this is an example of uniform flow. However, if the flow that is taking place through a tapered pipe. So in the case of tapered pipe, the cross-sectional area of the pipe is changing from section to section. So in that case, the velocity changes from section to section. So if the velocity at a given instant changes from point to point, then the flow is described as non-uniform. In that case, dou n by dou s, that is not equal to 0. The example is the flow through a tapered pipe. So if you are moving from one section to another section, since the cross-sectional area of the pipe increases, the velocity get reduced. So that means for a tapered pipe, though the flow rate is same, flow velocity that changes from section to section. That is dou n by dou s not equal to 0. In the case of the flow through the pipe, dou v by dou s equal to 0, whereas for the tapered pipe, dou v by dou s not equal to 0. Next is steady flow. In steady flow, flow characteristics at every point do not change with respect to time. In steady flow, the flow velocity or pressure, etc., that may change from point to point, but it do not change with respect to time. That is dou n by dou t, that is equal to 0. Whereas if the flow characteristics, velocity, pressure, etc., that changes with respect to time, then the flow becomes unsteady. So in that case, dou n by dou t not equal to 0. So let us go and see this in illustration. Figure shows a rectangular channel flowing with a constant rate of flow. So since the cross-sectional area of the channel is same throughout the length, then if you are measuring the flow characteristics from point to point, it is same throughout the length of the channel and it is not changing with respect to time. So if you are measuring the flow depth or flow velocity at various sections, they are same throughout the channel. So this is an example of steady uniform flow, that is flow characteristics are not changing with respect to space and time. That is dou n by dou t that is equal to 0, whereas dou n by dou x that is equal to 0. However, in this case, though the flow rate is same, the cross section is changing slightly from this point onwards. So that means here, though flow rate is same, due to the change in cross-sectional area, the flow characteristics are changing from section to section. So it is an example of steady non-uniform flow. Here, dou n by dou t equal to 0, whereas dou n by dou x that is not equal to 0. So flow characteristics are changing from point to point, but not with respect to time. The figure shows a pump which is drawing water from a sump and it is discharging out through a delivery pipe. During the pump startup, the flow rate is changing from 0 to the maximum. So if you are considering at a particular instant of time, then if you are measuring the velocity at various sections, because here this pipe is horizontal and the cross-sectional area is same, then you can see that the velocity is not varying from section to section, but it changes when the time progresses. So at a particular instant of time, the flow characteristics are constant from one section to another section. So this is an example of unsteady uniform flow. So in unsteady uniform flow, flow characteristics are constant with respect to space, but it changes with the time. So here dou n by dou t that is not equal to 0, whereas dou n by dou x that is equal to 0. So at a particular instant of time, all the flow characteristics are constant from one section to another section. So in this figure, you can see that the flow that is taking place at a constant rate through a rectangular channel, since the cross section is not changing along the length of the channel and flow rate is same. So it is an example of steady uniform flow. So to this channel, some flood is entering. So during the travel of this flood wave, what is happening is the flow characteristics are changing with respect to time. So it is an example of unsteady uniform flow. The flow taking place through a river during heavy rain is an example of unsteady non-uniform flow. For a natural river is concerned, the cross section is changing from section to section and the flow rate is also varying. So the flow becomes unsteady non-uniform during rainy season in a river. So we can say that dou n by dou t that is not equal to 0 and dou n by dou x that is also not equal to 0. Now we can summarize the type of flow. There are four possible type of flow. One is steady uniform flow, that is flow characteristics do not change with the position or time. Example is flow of liquid through a pipe of uniform cross section running completely full at constant velocity. So here dou n by dou t that is equal to 0 and dou n by dou x that is also equal to 0. Second case of flow is steady non-uniform flow. So here flow characteristics are constant with respect to time, but it is changing with respect to space. That is flow of liquid at a constant rate through a tapering pipe running completely full. Here dou n by dou t equal to 0, whereas dou n by dou x that is not equal to 0. So here the cross section is changing, so characteristics are changing from section to section. Third case is unsteady uniform flow, that is at a given instant of time, velocity at every point is same, but this velocity will change with the time. The best example is accelerating flow of liquid through a pipe of uniform cross section running completely full, such as would occur when a pump is started up. So here dou n by dou t not equal to 0, whereas dou n by dou x that is equal to 0. The fourth case is unsteady non-uniform flow, So in this case, flow characteristics are change with respect to space and time. That is the flow of flood through a river. So dou n by dou t not equal to 0 and dou n by dou x not equal to 0. Now the session comes to an end. We had enough discussions about the type of flow with examples. Our next video is regarding pattern of fluid particle and velocity and acceleration, and all the related problems are discussing during the class itself. For the time being, it is enough. Thank you once again. Yours, Sumam.